Hello everybody, welcome to Abbhi Chemistry. As you all know, everything in the world is made up of matter, and matter is made up of elements. These elements are 118 in number, and they are classified. And it was classified by the periodic properties. So in this chapter we are going to discuss about periodic classification of elements, which was the work of 3 successful people, but they failed at start. Later on, many scientists started working on that. So let's discuss about these scientists in this chapter. Who are they? Who are those scientists? What did they do? What is the pattern of arranging them in that order? So these are the 3 questions which pop in every person's mind. What did those 3 successful scientists do it? And why did they do it? Let me start with the first question. Who arranged them? 118 elements in a particular order. John Wolfgang Dobereiner. Dobereiner was a German chemist. Who started working with elements. He found a pattern which is constantly repeating itself, and he called this pattern as triads. And since Dobereiner discovered it, he called this one as Dobereiner triad. So what is a triad? Triad is a set of trees or 3 elements arranged in the order of their atomic masses. And what is the pattern he observed? The atomic mass of the middle element was roughly the average of the first and the third element. Let's look at the examples. Let's go for example 1. Example 1 consists of lithium, sodium, potassium, which are arranged in the form of a triad. The atomic mass of lithium is 6.9. I'll be taking as 7. The atomic mass of potassium is 39.09. I'll take it as 39. Adding them both, we get 46. Now average of this 46, that is 46 by 2, 23, is the atomic mass of sodium. So this is the pattern which Dobereiner guy observed. Example 2, we have calcium, whose atomic mass is 40, barium, whose atomic mass is 137. Adding them both, we get 177. So average 177 by 2, that is equal to approximately 88 point change. So this is very much near to strontium. So this is also a triad. Example 3, we have chlorine, which is 35.5 approximately. Iodine 126.9. So adding them both, we get around 162. So 162 divided by 2, that is average, we got 81, or somewhat similar to 81, which is nearly equal to 79.9. So This is what called as Doberan's triads. This guy is the first successful person in classifying the elements based on the triads he discovered. But he failed. Why? Because there were only 3 triads were made, but there are many elements which were not classified, not discovered, and cannot be placed in this pattern, that is triads. Yet he is successful. So let's go to second scientist, story 2, John Newland. Newland is a British chemist. He started arranging elements just like Doberan. But he found a new pattern this time and he named it as Octaves. By the way, I forgot to tell you, this Newland is fond of music. And he called them as Newland Law of Octaves. He called them as Newland Law of Octaves. And by the way, what are octaves? Octaves are like, you see, every 8th element had properties similar to that of the first element, which is told by this person, Newland. For example, say, Sa over here is repeating after Ni. Elements are not similar. The properties of the first element and the 8th element are similar. You can see the example here on the screen. Hydrogen has similar properties with fluorine. Lithium properties are similar to sodium.
Beryllium properties are similar to magnesium. Boron properties are similar to aluminium. Carbon has similar properties to silicon. Nitrogen has similar properties to potassium, and oxygen has a similar properties to sulfur.
This is what Octave tried to explain, that the first element and the 8th element will have the same properties. Every 8th element will have similar properties of the first element. But he failed. Why? Because the pattern was applicable only up to element calcium. Only 56 elements were discovered at that time. He adjusted 2 elements, that is cobalt and nickel, in one slot only. Iron, which had the properties of cobalt and nickel, but placed very far away in this periodic table. Moving in the path of success, there was another scientist, Mendeleev. He was a Russian chemist. He took the work of Doberan theory, that is atomic mass theory, Newland's theory, that is classification using the chemical properties, and established a connection between them both. At the time of Mendeleev, there were only 63 elements which were present. He started experimenting them by the ability to form hydrides and oxides. That means how they are reacting, how the elements were reacting with hydrogen, oxygen. So this was one of the criteria he chose. He wrote the formulas on the cards and pinned them to the wall, as you can see on the screen, to find out some similarity between physical and chemical properties. While he was trying to find out the similarities between physical and chemical properties, he just defined a periodic law. He felt that the properties of the element are the periodic functions of the atomic masses. As seen on the wall, he termed vertical columns as groups, and horizontal rows as periods. This arrangement was called as Mendeleev's periodic table. Okay, now what are the properties he observed? Let's take this one as the first group is hydrogen lithium. Now hydrogen react with water to form H2O. Similarly, lithium reacts with oxygen to form Li2O. Sodium Na2O. Beryllium, now second group, if we go for second group, it reacts with beryllium forming BeO. Magnesium forming MgO. Calcium forming CaO. Zinc forming ZnO. So when they are reacting, when the first group is reacting, you can find Li2O, Na2O and K2O, H2O, etc. When second group is reacting, it forms BeO, MgO, calcium oxide, zinc oxide, beryllium oxide, magnesium oxide, calcium oxide, zinc oxide. And here water, lithium oxide, sodium oxide, potassium oxide. So these properties has led to the arrangement of the periodic table based on the atomic masses, and this is nothing but the periodic law. So what's the periodic law states? The properties of the elements are the periodic functions of their atomic masses. So the properties are depending upon their atomic mass. The properties are depending upon their atomic mass. So this was given by Mendeleev, hence Mendeleev periodic law. There were some achievements by Mendeleev when he was like, yay, I achieved something. Hey, what did I achieve? Huh? Okay, then he found that the elements with slightly greater atomic mass were placed before the one element with a slightly lower atomic mass. For example, atomic mass of cobalt is 58.9 is placed before nickel, whose atomic mass is 58.7. So here and there. He left some gaps. You can see in the periodic table, on the wall of Mendeleev. So he left some gaps for the predictions. So that was very good thing for the existence element that were not discovered. He know few elements, but he could not name them. So what did he do? He used the word Sanskrit numeral called eka, which means preceding before it. Eka means before. Eka means before. So like eka boron, eka aluminium, eka silicon. So eka boron is called as canadium. Eka aluminium is called as gallium. And eka silicon is called as germanium. There were 4 limits for him. That is position of hydrogen. Hydrogen is actually a different compound. It has the properties of group 1, that is extreme left. It also has the property of group 7, that is to the extreme right. So it was a big puzzle for Mendeleev and many other scientists. So the exact position of hydrogen was not known. So that was his limit. Next, position of isotopes. What are isotopes? Isotopes are nothing but which have same atomic number but different mass number. For example, if I take hydrogen, I have same atomic number and mass number as 1. So if I take again same element hydrogen and different atomic number H1 3. So they have same atomic number but different mass number. They have same atomic number but different mass number. They are called as isotopes. So the position of isotopes was not clear. Anomalous pair, potassium and argon, and tellurium and iodine. Potassium and argon are having same mass number, approximately same mass number. So it was very hard for him to arrange this pairs. So hence they call it anomalous. Anomalous means puzzled pairs. So at the starting of the lesson, I told you all that there are 3 successful people, but they failed. Why? You can see on the screen right now, the arrangement, the red color is unknown to Mendeleev and blue color was the Dobrynov triads and yellow color represents the elements which are known to the Mendeleev. They were all placed in one periodic table which led to the path of the success. They were successful but failed in the start. That's what made them our greatest people, because they failed but they laid a path to the success which we are presently using in the form of periodic table, which has been completely modified by Mosley. There is one more scientist, the fourth scientist, who has taken all the three people's work and laid it in a form of a single card periodic table, and this is nothing but Mosley's periodic table, or we can simply call as modern periodic table. The next we are going to learn about is Henry Mosley, who is also a successful scientist. He never failed. This project has never failed because he combined the work. He combined the work of the three scientists, that is Dobereiner, Newland, and Mendeleev, and made it into a new modified version. The modified version of his own theory. That modified version of his own theory is called as modern periodic law. It clearly mentions saying that what is the modern periodic law? Modern periodic law states that the properties of the elements are the periodic functions of the atomic number. And what is atomic number? Atomic number is nothing but the number of protons. Atomic number is nothing but the number of protons. It depends upon the atomic number. Say atomic number 1 is hydrogen, atomic number 2 is helium, atomic number 3 is lithium, atomic number 4 is beryllium, etc. Based on modified table. So what he did, he modified the entire table, arranging the elements based on the atomic number, and called it as modern periodic table. So let's look over here. This is the modern periodic table at present which we are using. In this we have hydrogen separately placed, okay, and these are the group numbers: group number 1, group number 2, 3, 4, up to 18, right? And these are the periods: 1, 2, 3. These are called the periods, right? If you look on the extreme left, the small boxings which I am doing, these are nothing but metals. And the extreme right, the yellow and the blue part, are non, and this green part, slightly dirty green part, is called as metalloids. Now you can find the entire middle box over here. This entire middle box are called as transition elements. This lower box, they are called lanthanides and actinoids. Which you will be learning in the next classes. Okay, let's discuss about the modern periodic table. The modern periodic table has 18 vertical columns known as groups and 7 horizontal rows known as periods. The elements are placed in a group based on the number of valence electrons. What do you mean by valence electron? Say, for example, you're taking an atom. This is the nucleus in the center. Around it, you have the electrons revolving around it. This is known as the valence shell, or the outermost orbit, valence shell. In this valence shell, the electrons which are present is called as valence electrons. Now what is the valency? there are 4, so I can say that there are 4 electrons. So the valency belongs to group 4. Belongs to group 4. Okay. Similarly, now the elements are placed in the periods based on the number of shell. Say, now this one is shell 1, shell 2, shell 1, shell 2. So this atom is belong to period 2. Period 2, and what's the group? 4. So he tried to assemble everything. He tried to give a property to it, and he has discussed everything about it in the form of trends of periodic table. So next we are going to learn is trend of periodic table. So as you can see here, the first period consists of hydrogen and helium. This contain only 2 elements. And the second period consists of 1, 2, 3, 4, 5, 6, 7, 8 elements. Third also 8 elements. Fourth 18 elements. Fifth 18 elements. Sixth group onwards, you'll have continue from here, that is 32 elements, and the seventh group will also consist of 32 elements. So first group 2 elements, 8 elements, 8, 18 elements, 18 elements, 32 elements, 32 elements. This was how it was divided by Mosley. So to find out the number of electrons, we use a formula called 2n square. And if you take an element, it has made up of different shells where the number of electrons revolve around the nucleus. So the shell which is next to the nucleus is the K shell, and next to the K shell is the L shell, and next to the M shell, next to the L shell is the M shell. So for K shell, they have assigned the value 1, 2 and 3. And N is nothing but values assigned to the shells. For example, if you want to find out the number of electrons present in the K shell, so you have here 2 into 1 square, that is equal to 2 electrons are present. If you want to find out how many electrons are present in the L shell, then 2 into 2 square, that is 8. 4 to the 8 electrons are present in the shell. In the M shell, 2 into 3 electrons, that is equal to 18 electrons are present. This is how the number of electrons are calculated based on it. The same thing is repeated in the number of elements present in each. Okay, now let's discuss about the trends in the periodic table. What are the trends? What is repeating? Okay, so the basic point first we are going to learn is about the valency. So valency is nothing but a group number. Say this is group 1, group 2, group 1, group 2, group 3, 4 and up to 18. So this one gives the group 18. So what is group number? The number of electrons present in the outermost shell. The number of electrons present in the outermost shell is nothing but the group number. This comes under valency. This is nothing but valency. Next trend in the periodic table is atomic size. As you go from left to right in a period, in this direction, the atomic size decreases. Why? Because the nuclear charge increases. As you go from top to bottom, that is in a group, atomic size increases. Why? Because the number of shells increase. The metallic character. Metallic character is described by how fast an element can lose an electron. As you observe over here, say forget about hydrogen. So the metallic character in a period from left to right decreases because non-metallic character is increasing. And from top to bottom, that is from lithium and beryllium in this direction, the metallic nature increases. The metallic nature increases because larger size easier to remove the electron. Larger size, so easier to remove electron. And here it decreases because of smaller size. So smaller size nucleus will hold the electrons together. It will be very hard to remove an electron. So the metallic character in a period decreases, in a group from top to bottom increases. Thank you all for watching this. This is one entire chapter, periodic classification of elements. Thank you all. I hope you all like it. Please like, share and subscribe.